So why is it that the formula for an inverting op amp is feedback divided by input resistor value, but in the case of a non-inverting amplifier, you have to add 1? Well, let's step through some of the rules for op amps. The first rule is that the input impedance is very high on op amps, and for an ideal op amp, the input impedance is infinite. So that means that there will not be any current flow. There's no current flow into or out of either the inverting or the non-inverting input. The second rule is that the output impedance, the impedance of the output of an op amp is very low, and for an ideal op amp it would be 0. So that means it's going to be able to provide as much current or voltage as needed, depending on what circuit configuration we have, and in this case we have feedback. And then the third rule is that whatever the voltage is present on one input is going to equal the other input, and the reason for that is because we have negative feedback. So let's just step through the inverting amplifier configuration. We know that since our non-inverting input is ground, we've got 0 volts here. So by definition, we have negative feedback. So the op amp, because it has feedback, it's going to adjust its output to make sure that the inverting input also equals 0 volts in this case. So with that in mind, if we say, we'll just keep the math simple, we'll say we've got 1 volt, and we'll just say 1 volt DC. So 1 volt DC in, the inputs are 0 volts, so that means that we have a 1 volt drop across that 1K resistor. Well, then that means if we've got 1 volt across 1K, we've got 1 milliamp of current flow through this circuit, and we don't have any current flow into the negative terminal, or the inverting input. So now we have, probably drew the direction of the current wrong, depending on if you're using conventional or electron flow. In any case, current flow through these 2 resistors, we're going to have 1 milliamp through this resistor as well as that one. So that gives us 10 volts. And so because this is an inverting input, 10 divided by 1 is a gain of 10. So 10 times 1, 10 volts, but it's an inverting, so it's minus 10 volts. And you can also look at it in terms of, if you take a meter and measure across this resistor, that's minus 10 volts to our, I guess this in this case is a virtual ground. It's 0 volts. But our signal is here with reference to ground. So that's the inverting amplifier. The non-inverting amplifier, we step through the same process. We say, okay, 1 volt is applied to our non-inverting input, and that means that we have to have 1 volt. If 1 volt's present on the non-inverting pin, it has to be present on the inverting input because we have negative feedback. And now again, so now we've got 1 volt here. Our ground reference is here. So that means we have 1 volt applied in this polarity. Notice how that polarity is opposite now from the inverting circuit. And again, we've got 1 milliamp current flow, 1 volt divided by 1K, 1 milliamp. And so 1 milliamp, 10K through 10K is 10 volts. So what's going on here is that, ultimately, it's in blue, 1 volt times 11, because we have 10 divided by 1 is 10, plus 1 is 11, gain of 11. So we should have plus 11 volts out. Well, where is that 11 volts coming from? Well, we've got 10 volts across this resistor, but now the difference is our ground reference is here. It's no longer here. And so that plus 1 is this additional signal dropped across that resistor, the input resistor. We don't care here because our reference is here and our virtual reference is here. But in this case, in this configuration, you have to factor in this. This is part of the output now, because it really comes down to where in the circuit you're referring the signal to, and in this case, the reference is here. So you have to add this. This is where the plus 1 is coming from. Hopefully, that explains things or helps the understanding of where this plus 1 is coming from. I should also mention too, this plus 1 becomes less and less of an issue the greater the gain is. So if you've got a 100K or 300K, for example, divided by 1, well, there's your gain of 300 plus, 300 or 301. Well, it's not a huge difference. I suppose if you have quite a bit of gain here, the plus 1 doesn't factor in so much and you can ignore it, but it becomes more of a factor the closer to 1 you get. So in any case, if you found this video useful or if you have any questions, let me know in the comments. And I look forward to seeing you in the next video. Thanks.